confuse you at all. All right, round two, ready and fight. Okay, I want to use the quadratic formula to find the two zeros. Remember, it could be called a zero, a solution. It could also be called a root. I refer to them all as x-intercepts. Okay, we're trying to find where this parabola crosses. I'm not sure where it's going to cross, but it's going to find the two values. And the reason the quadratic formula is very useful is like on this one, if I tried to factor it, it's not factorable. I mean, I can prove it to you. I can slide and say, okay, negative 12 would come up here. Negative 6. Well, 12 times 1, 2 times 6, 3 times 4. These have to be different signs to get a negative up there. So the difference of my factors needs to be 6. Notice I don't have any factors that fall in that category. Okay, so that's why we need the quadratic formula. Okay, x equals opposite of b. I'm using capital letters right now, plus or minus square root of b squared minus 4ac divided by 2a. Hey! Okay, I want you to write a, b, and c over here. A is just the number in front of the x squared. These are always in the format, ax squared plus bx plus c. Okay, so then a on this one is going to be 3. B, it says, is negative 6. C is negative 4. I'm suggesting you write negative 4 times A times C down here because I've done this a long time, and if kids are going to make a mistake, it's going to be here. So I'm going to write negative 4. A is 3. C is negative 4. Negative 4 times 3 is negative 12. Times negative 4 is positive 48. Okay, so when they ask for minus 4ac, I'm going to plug in. Its sub will be 48. Okay, let's start. X equals opposite of b. Opposite of negative 6 would be positive 6. Plus or minus square root of b squared, which happens to be 36, because negative 6 squared is equal to negative 6 times negative 6, which will be positive 36. Okay. B squared minus 4ac, which in this case is a plus 48 because we did it over here, divided by 2a. 2 times 3 is 6. You're almost done. Now we just have to simplify. Okay, you always do under the square root first. So x equals 6 plus or minus 36 plus 48. 4, 5, 6, 7, 8, 4. I get 84. Okay, well, 84 does not have a perfect root. It's not a perfect square, so I'm going to prime factor. I'm going to take the square root of 84 and do what we did from last night. It's 2 times 42. That's 6 times 7. That's a prime. 6 can be written as 2 times 3. Okay, so I can write the square root of 84 as the square root of 2 times 2 times 3 times 7. Guess who's coming in to ask a question? Any pairs in there? This guy's looking for a pair of numbers that match, and the 2's match, so they get to come out. So the square root of 84 is simply this, 2. What's left over? The 3 and the 7, which is 21. Okay, so I'm going to come back over here. Instead of the square root of 84, I'm going to write 2 square root 21. Now, there are two answers here. First of all, I have to check and see if anything is reducible. You cannot look inside the radical. The radical just stays. Never try and reduce within the radical. What I want you to do, though, is look at all the numbers that are outside. If all 3 of them are divisible by the same number, then you can reduce it. Otherwise, you just leave it. But I see 6 is even, 2 is even, and 6 is even. All 3 of those are divisible by 2. So 6 divided by 2 is 3, plus or minus. 2 divided by 2 is 1. So there's really a skinny 1 there. And 6 divided by 2 is 3. Don't try and cancel those. They don't cancel. But here's how you would write your two answers. Okay? Sometimes they write it like that, but they could also write it like this. Well, remember, one of our answers says use the plus, use the positive. So I'm going to write 3 plus square root 21 over 3. And the other answer would be 3 minus the square root of 21 over 3. I have no idea what that equals, but they could write it like that. And I have a feeling that's how they write it today. That's one answer, and then they'll put a comma, 3 minus square root 21 over 3. Those are my two zeros. I can guesstimate what it is, and then I could probably figure out my graph. But you know what? It wasn't factorable, and who would think that I could ever get that with